So now we're going to drill this hole here for the indicator. What I'm going to go ahead and do is I'm going to lay out the clamping bolt. There'll be a clamping bolt here, clamping socketed screw here. I'm going to lay that out first so that we can figure out where I don't want to put it too close. I want to leave myself a little room to get the tool in here so that it's easy to get a large indexable tool, for instance. I could use this as my pacemaker, so I don't want it too close up here to the block. I want it out. That's why I left enough room here for us to put it out of way. So I'm going to go ahead and lay this clamping bolt out so we can figure out where to put the hole for the indicator. Alright, back in the middle here. I've laid out where I want my clamping bolt to go. I'm going to use a 1/4 inch socket head cap screw. So I've placed it here pretty close to the end, showing to leave about 1/10 of an inch between my for my countersink for my socket head cap screw here on the end. Then using that information, I calculated out the total distance that I had left, and I don't know if you can see there's a little line on there where I'm going to put that the through hole for the indicator, which works out to almost exactly 3/4 of an inch from this end. So when I drilled this hole, the part was sitting in the vise like so, and now what I'm going to do is I'm just going to turn it this way, mount it in the vise like so. Then I'm going to use my edge finder to pick up this edge without changing my Y, and then just come straight back 0.754, like I said, almost exactly 3/4 of an inch. And then I'm going to drill my 3/8 inch hole. Well, I'm going to drill undersize and then ream 3/8 inch hole for the barrel of the indicator right here. Then we'll take it out and we will drill and countersink and tap the hole for the locking bolt. So let's get the edge finder out. Alright, we got the edge finder in the chuck. Let's see what our RPM is set at. That's good. There we go. I'm going to zero my X on my DRO. Go ahead and pull the edge finder out. And get my drill in here to drill that 3/8 or drill undersize and ream that 3/8 hole. Alrighty, we got a 23/64. It's the closest thing I have to 3/8 in the drill chuck. We're going to come over our 754 here and lock my table, and we're going to knock this hole out. Alrighty, hole is drilled. Let's get rid of the chips. Let's mount the reamer up and ream this thing out to 3/8. Alrighty. Let's slow this puppy down. Reverse the spindle. Lube liberally. Alright, there's our reamed hole. Alright, so that's our hole for the indicator right there. So let's get about to drilling and tapping and countersinking the clamping bolt hole, and we're getting really close to figuring out how far off center height all my current lathe tools are. So I've been thinking about that. So let's get this set up to drill that hole. Get a little quick math. to countersink this 1/4 inch socketed cap screw. I need to come back from this side about 233, so I'm going to go ahead and pick up X on this and come back over 233 and pretty much just repeat the exercise without the reamer that we just did for the through hole here. So let's go ahead and pick up that X. I always like to pick it up, zero out my DRO, and then if I'm thinking about it, go ahead and back up to it without looking at the DRO. Back up to your edge, that edge finder, and see if you repeat. And if you can complete the 3 digits on the DRO, you're doing fine. So supposedly edge finders are only good to 3 to 4 thou anyway. So I've never done any work to actually verify that, and that might be a fun little project here. So let's go ahead and get number 7 tap size for this screw in this drill all the way through. Make sure you compensate for the diameter of your edge finder. Made that mistake many times. There we go. Alright, let's fire it up. Alrighty, let's get a counter bore set up here, and let's counter bore this down for the depth of that socketed cap screw. Alright, we've got our counter bore here for our socketed cap screw. What we need to do now is slice this baby open and then tap the back side for the clamping bolt, and then drill this side out to a passage hole. Alright, we're going to get set up to slit this piece right here for the clamping bolt. And what we're going to use is a tool that I made quite some time ago that uses a small carbide trim saw blade. These things are available at your big box store for about $7 or $8. Alright, okay guys, we're set up here. We got lube ready to go. We've got our air. We're going to have a air blast going here. I'm going to use WD-40 as my cutting lube here. And I got it in back gear, pretty much I think about 70 RPM, about 60 RPM as low as this thing will go. So kick the air on. And just a quick something to show you, if you've never used slitting saw before, here's a trick. You don't just plunge in and make a big cut, right? First thing I do is take a shallow cut all the way across the workpiece. That sets a groove in the workpiece, and then the saw tends to follow that groove. So this kind of helps you make a straight cut. Lots of times, if you're using a thin saw and you're cutting a great depth into it, it'll move around, and you'll get a curved cut. And so we're going to make a thin cut all the way across the face. Then we'll come back and increase the depth of cut. Okay, let's move the camera around here a little bit. So there you go. You can see the cut that we put on there. And now we're just going to start making some repeated cuts and get this sliced through. That's a 1/10 of an inch cut there. Alright, we're getting ready to make our last cut here. We're going to break through on this cut. Been using the coolant system here that y'all might have seen in some other videos. And it's working great. It does a real good job of keeping the cutter free, flushing out the chips. These are little bitty chips, obviously. And and my RPM's up to about 130 now. I'm running at about 130 RPM. So let's get it going here. Cut off the coolant there. Anyway, go ahead and pull that out. I'll give you a better look at this thing too while I got it out of the mill here. Alright, we got our part cut in half here. But what I want to talk to you about real quickly is this little saw arbor that we use. Again, this is a 3 3/8 inch trim saw blade. It says here it's made by a company called Oldham. It's 24 tooth, 3 3/8 carbide tip blade. It's made for these little rechargeable, little battery powered saws, trim saws used in the construction industry. Part number I think is 338C432, and I think I paid like $7 or $8 for this. If you want to make an arbor for it, here's my arbor for it right here. If I remember correctly, excuse me, that's 15 millimeters, 14.75 is the size there. I've got a shoulder turned in here where the blade sits on there, and then I've got this, the interior here tapped, drilled and tapped for a 3/8 by 24, 5/16 by 24 bolt. And it's just a right-handed thread. It's not a left-handed thread or anything like that. And there you go. That pretty much makes up the arbor right there. And I've got flats turned down here to use it in a 3/4 inch end mill holder. And there's a little shoulder here that it indexes in the holder. So anyway, this is a neat little piece. These little blades are nice. They work great, and they're cheap. So this is a great little tip for saving money. If you got slitting saws, this is typical of a lot of slitting saw sizes, and so this is a really nice little piece if you have need for that type of functionality. Save yourself some money. Anyway, so we got all of our parts done here. So what I'm going to do now is I'm going to go ahead and trim this off to a reasonable length and chamfer the end there, and then trim this off about half of this down, and probably end up actually this is hard. I'll end up cutting this on a chop saw and then grinding it down just to make the end smooth. Tap for our clamping bolts, and then we're going to do a little cleanup. We're going to put this baby together, and then we're going to have some fun. What we're going to do is we're going to put it in my lathe, and we're going to figure out how off all of my existing tools are from true center height. So I thought that'd be interesting for me without adjusting anything. Go ahead and see how close I was with my other traditional techniques for setting center height. So I'll go ahead and get this finished up. I'm not going to burden you with cleaning and tapping. So next time you see this thing, we'll be in the lathe and we'll be putting it to use. Alright, we got our setup here in the lathe, and I've played with it a little bit, and I got to tell you, this may be one of those things that is best done by those with OCD, which isn't me. But anyway, let's talk about it. So I got it chucked up in the collet here. I used a square to square it off the top of the cross slide, and not that that matters to calibrate it. I put the dowel pin in here. I the indicator, zeroed the indicator, and then I lowered the indicator into the chassis until it was reading 150 thousandths, which is over halfway, right? It's 125 to the middle of this dowel pin. I tightened the screw down here with the old hex wrench. I tightened this down, clamping it, and then I dialed in 25 thou and clamped the bezel. So this thing should be set when you get it to 0. You are at 125. Well, so then I put a tool holder in here. Let me see if I can take that out. Let's see. Try to move this around a little bit. I put a tool in. Put that on the point. Now I don't know if you can, how well you can read that here. Make sure. Tell you what, I'm going to try moving the camera up a little bit. Okay. So there we're reading about 4 thou high. Now watch this. The tool is tight. The tool is tight in the tool post right now. Loosen the tool post. Tighten the tool post. Now what's happening is, it's not moving. What's happening is, when you loosen the dovetail, the force of the indicator, the spring force of the indicator, is causing the tool to rock on the dovetail. And when you pull it back straight, it clamps and comes back up straight. So, and I've already played with this one. I was about 14 thou off on this particular tool, the way it was set. So that, you know, I'll tell you right now, the way I normally set my tool height is either just by eye off of the center in the tailstock, or using the old ruler method, and probably the ruler method if you gotta know the truth. So I was about 14 thou off. So then I got to playing with it, and I said, okay, what's going on? And that's when I noticed this particular deal. So what I had to do was, while I was setting this height, is I had to try to compensate for that effect right there. Maybe different with different tool posts, or different size tools, or different indicator, right, with a spring that isn't quite as aggressive maybe. But all in all, just fiddling with it a little bit, I've gone from 14 thou off to 4 thou off, and I've just started playing with it. So I thought what we would do now is get some of my other tools, and 0 is dead center right here, right? So let's get some of my other tools, and let's try them out, and let's see how far off I am with those. Alrighty, here comes another tool. Alright, I'm pretty close on that one. I'm only about a I'm about a thou low on that one. That's not too bad. Now, same thing, if I loosen it, it'll rock on here, but if I tighten it up, I'm about a thou low. That is not bad. I'm not even going to mess with that. Let's try another one. Here's a parting tool. If there's ever one that you want to be right, this is it. Alright, I'm about 5 thou. Someone's here. About 5 thou high. I'll have to adjust that and we'll be right back. Okay, like I said, I'm about 3 Lomo parting tool here. And you got to kind of okay, about a half. Oops. That's pretty good right there. Let's see how it repeats. There. That's right on the money. Okay. Let's try another one. So I haven't been as bad. I guess that first tool is the worst one. Yeah, this is a cemented carbide threading tool. Oh boy, I'm almost 10 thou. Oh, hold on a second, never mind. Oh, not too bad. About half a thou. I don't even know if I want to mess with that. You can certainly see how this is pretty useful. The primary thing to watch out for is make sure that you use a square. I'm going to back this up here, put a square on it, show you how I did this. So I just ran a square up here right along this edge and then adjusted my chuck this way here, back and forth, to get it square here, good and square with the top slide, the cross slide. So now this is one way to use this piece here. The other way to use it, obviously, would be if you had a DRO, you would kick it around this way, and then you could find center again. It's the same number, right? You don't have to even adjust. You don't even have to adjust the indicator because it's already found center. You make sure it's horizontal, and then you just feed this in like so until you hit 0, and then set your offset on your tool number on your DRO, and you're good to go. So as long as you number your blocks and your DRO has an offset function, that's all you need to do. Works both ways. So I'd say this is a very little useful piece of equipment, and I am very pleased at the original poster's idea, and I'm glad that I made it. So I'm going to bring it back over here so we can just do a little summary here. Alright, so there we go. Oh, there's my little dowel pin. Here's my shortened dowel pin. There is our center height finder. It's a handy little piece of kit, as the Brits would say. I'm going to have to get over to the wood shop across the street and make me a little storage box for this. Get me an indicator with a flat base, because I don't think I'll be changing this much. I did post a revised drawing on the Coolant Mister series. If you go back to the first one in the series, I posted a revised drawing of the coolant block with the revisions for the new needle valve for the 1/8 inch pipe needle valve hookup, and including the dovetails for mounting the blocks using a dovetail like an indicator. And I also took out the number 7 holes that I did not put in the blocks and I did not tap. So there is a revised drawing in the first video of the coolant of the Fogless Mister series. And we got some more stuff coming up real soon, so things are busy around here, as they are everywhere, it looks like. And I thank everybody, all the subscribers, all the posters and commenters, good and bad. Bring it. I like the ideas. I like the I've learned a lot from a lot of people out there, not just the other people posting on YouTube, but the commenters as well. A lot of very thoughtful comments by obviously very intelligent people. So have a safe weekend, have a good Veterans Day, and be safe in the shop.